Hello and welcome back to my science channel. Gary of DraftScience has been going on and on about how kinetic energy is not 1/2 mv squared. Perhaps it's mv, which is just momentum. But he is absolutely correct that you cannot find one single experiment which objectively measures with measurements to show that the kinetic energy formula is in fact 1/2 mv squared. And the squared makes a big difference. So if you're just going, say, twice as fast, 2 squared is 4. So the amount of kinetic energy of an object going just twice as fast should be 4 times as much, which is, kind of hard to believe. So I wanted to come up with the simplest experiment I could think of to show whether this was either mv squared or mv. Now the only other experiment you can find on the internet is like the air table collision things, but as I showed in my previous video, whether you use mv or mv squared, they both end up being equal. So that kind of experiment cannot actually tell the difference between mv squared and mv. It's useless as an experiment to do that. So this is what I propose. I'm going to propose that since Gary likes cars, I have a car. So I have my model Corvette here, okay? And we're going to set my model Corvette going at some speed, right? And so the thing is that if I get my Corvette to go, say, just twice as fast, then it should have 4 times the energy. And what I'm thinking is that I'm going to roll this down my floor, and we're going to go and find out how far it goes. So let's take a look at this setup here. Okay, so this is the simplest thing I could think of. So what I've got is I've got a ramp here. And I've marked the halfway point here, right? So no matter what angle I place this on, or no matter how my ramp is built, theoretically, if I start my car here, it should go through the gravity potential twice as long and obtain twice the speed of if I put it halfway. So that's the basic principle. And then we're just going to see how far the car goes, okay? And we're going to see whether if it goes like 4 times further when I just use the middle mark versus the top mark, okay? That would be the prediction, okay? So let's just give this a try. So I'm going to put the back wheels right on that mark there, and I'm just going to let it go. There it goes. So the thing is that as the car rolls, it's going to absorb the kinetic energy. And so theoretically, the amount of kinetic energy the car has should correspond to exactly how far it got, which is just under 6 feet, okay? So let's give it theoretically twice the velocity by putting it up twice as high as before. And let's see what happens. And there it goes. Okay, definitely goes further. But how much further? Okay, so we've got about 11.5 feet there. Okay, so what does this mean? So when we apparently gave the car twice the velocity, it only went about twice as far. So this would mean that this is more closer to being 1/2, well, not even that, it just says mv, right? Because if it was mv squared, it should have gone 6 times the amount that the single velocity, initial velocity, would have. So it should have gone 24 feet, and I don't even have 24 feet here, so it obviously didn't do that. So I would have to say that this little experiment what kind of confirms Gary's suspicion that kinetic energy is really like mv. because it doesn't look like it was mv squared here. Now, I haven't done any, haven't examined the frames or made any careful measurements of how my car works or whether the ramp is perfectly straight or anything like that. I'm going to leave that as an exercise to someone else. This is just a way of demonstrating how you can actually possibly measure this in an actual objective empirical experiment. So let me know what you think, and try it on your own if you think you can do this experiment better or find out what I did wrong.